Hello folks, welcome to a physics lesson, uniform circular motion. Uniform circular motion, that is book 4, chapter 2. Okay? Now, uniform circular motion in a nutshell is simply motion in a circular path or in an arc. Okay, that is part of a circle. So I want you to understand it is just motion in a circular path, or we put it in a simple term, in a circle. So there is a circle and you are moving along there, so you exhibit circular motion. I think that would be better. Now, when I say in an arc, when you are driving, sometimes you negotiate a corner, so you don't see a circle, but that is part of circular motion. Okay, when you whirl something vertically, that is still circular motion. This is circular motion. Okay, circular motion. So these kind of motions are the ones we are going to study. When you go to the agricultural show or some places for entertainment, you also come across merry-go-round. That is still part of circular motion. So in a nutshell, we are talking about motion in a circular path or part of circle, arc, in an arc. Okay, that is the definition. Now I want us to consider here, I've drawn a circle for illustration. I am driving from point P to point Q along the circumference. So I'm driving along the circumference there. My circle is center O, and therefore, if I draw a line from starting point to O, it will be radius of my circle. And if I draw a line from where I stopped, point Q, to O, still this becomes radius. Now I want you to get what we have done before. You can get length of path taken along the circumference. That is, we can measure along this circumference the distance. What is distance? Distance is length of path taken. Okay? Now suppose I take my ruler and measure just from P to Q straight. If I measure from P to Q straight, from P to Q, if I do that, I get what we call displacement. Okay? Why? It is length of path taken in a given direction. Do you remember now? Scalar quantities and vector quantities. So along the circumference, it will be scalar quantity, because at the end of the day, it can be 3.5 meters or 7 meters or 15 meters. So that is size, scalar. But if I measure from P to Q on a straight line, there will be direction and there will also be distance. So in that case, we shall be talking of a vector quantity displacement. Right? Good. In moving from P to Q along the circle, let us give that arc length S. So I've moved from P to Q along the circumference and I've found it to be S meters. In doing so, the arc length has subtended an angle theta at the center. So what are we talking about here now? We have reminded ourselves what is distance. We have reminded ourselves what is displacement. And in mathematics, S has subtended an angle theta at the center. From the center to any point on the circumference is known as radius. Those are basic things. We get into business. Suppose in moving from P to Q along the circumference, okay, a body travels equal distances in equal time interval. Equal distances in equal time interval. Okay, so I cover, let's say, 10 in 2 seconds. 10 into 2 seconds. So if I cover 20, it will be in 4 seconds, and so on. That's what we say in equal time interval. Okay, so 10 is to 2. I add another 10, I add 2. I add another 10, 30, 6. Do you get it? That's what we mean. Equal distance in equal time interval. Do you get it? Equal distance in equal time. So I've covered the first 10 in 2. So if I cover another 10 in 2, in short, 10, 2, 10, 2, 10, 2, 10, 2. But if you want to analyze from beginning, you will talk of 10, 20, 30. Get it? Then down here, I'll talk of 2, 4, 6. What happens if that is the case? We will talk of the body will be said to have a constant speed. Constant speed. 10 over 2, 5. 20 over 4, 5. 30 over 6, 5. That is what we say constant speed. The speed has not changed. The size has not changed. Scalar has not changed. Okay? But at point P, this is now good stuff. At point P, if this body cannot maintain motion in a circumference, if let's say it is skidding, that is the way it will skid. It will skid tangentially. It will skid tangentially. What does that mean? If you draw a tangent at point P, that is the direction of skidding. What about at point Q? You draw a tangent there. Okay? If I draw a tangent at point Q, it gives me the direction. Better still, if it was at night and you stopped your car here, the headlamp will face that direction. Taa zitaangalia upande ule. Mwanga utajitokeza upande ule. If you come and stop at Q, okay, I've stopped at Q. There is no way your headlights will be facing there. No, they will face this way. So the headlights tell us the direction at any given point. What does that mean? I have the speed which we had 5, 10 over 2, 5, 20 over 4, 5. The speed, the size is still 5. Even at point P, 5. At point Q, 5. Even if I have another point here, 5. Another one here, 5. But when we stop at any given point, you will find the direction of your headlamps is different. Okay? It's different. So what do we say? But there is changing velocity. Why? Because velocity is made up of two things, size and direction. the size is still 5, but the direction at P is different from the direction at Q. So we say there is change in velocity. The bigger quantity here is direction changes, but speed is constant. Have you gotten it now? Right. What else? Because of velocity changing, we can also say acceleration exists, because acceleration is outcome of changing velocity. When velocity changes, then we talk of acceleration. Change in velocity may come as a result of either one or the second aspect of velocity, or both are changing. What do I mean? Velocity is made up of size and direction. Why? It is a vector quantity. So what am I saying? If velocity is changing, it means either the size is changing or the direction is changing, or both are changing. In our case, the size is constant, but direction is changing, and therefore we talk of acceleration. A body moving in a circular path with constant speed is said to accelerate. Why? You should be able to answer. Now, I want us to look at another thing here, angular displacement versus linear displacement. See, angular, the subject there is angle. Okay? So we have two terms. Remember, I told you, when I measure the length of path taken along the circumference, that one is called distance. If I draw a straight line from P to Q, that would be displacement. If this body moves along the circumference back to P, what will be displacement? Right, 0. Okay? So linear displacement is dictated by a straight line from starting point to the end point. Right. Then we have a new term that you must know now. Angular displacement. That any body which moves along a circular path subtend an angle at the center. So let me just get you right if you want to know this thing. So if I'm moving in a circle, okay, and I stop quarter-way of circumference, what angle in degrees is subtended at the center? Correct, 90 degrees, right? If I move from 12, okay, the minute hand moves from 12 along the circumference, its circumference up to 3. That is quarter of the circle. The angle subtended at the center is 90 degrees. If you have that, we are at home. So I want us to focus now on technical terminologies. I will focus our camera a bit down. So here we are. Angular displacement, okay, is the angle theta in radians. I'm introducing something new in radians. swept at the center when a body has moved through S along the circumference. We said let S be the distance swept along the circumference. Okay, so anytime there is a length swept along the circumference, there will be always an angle subtended at the center. But I am introducing a new measurement of angle, not in degrees, but in radians. Get it right? I will explain that. What is theta in radians? So it's not theta in degrees. But you will not get lost if you know the relationship between degrees and radians from mathematics. What is a radian? A radian is the angle subtended at the center of a circle by an arc length equal to radius. Oh, get that? So if here, and then I have that. Can we see? Can we focus down a bit? Can focus now. This is 12. This is 3. So we have, this is 90 degrees. That is understanding. From here up to here is what I've called S. Okay? With 90 you are at home, eh? But now we are talking about this. Okay? That this angle shall be called theta radians if R is equal to S. In other words, if this radius is equal to 10 centimeter, then this is also 10 centimeter. Then we talk of theta radian. Right? That is what the definition of radian is. Can we get it right? Yes. A radian is the angle subtended at the center. So this is a radian. That is 1 radian. If this and that are equal. Okay? So, if you come back up here, theta, angular displacement is a displacement in terms of angle. When does that happen? When there is motion along the circumference, that motion will always subtend an angle theta, and that theta is in radians. So in mathematics we say theta is equal to S over R, or S is equal to R theta. Remember, this is a ratio. This is a ratio. Therefore this is also a ratio, because we are told left hand side is equal to right hand side. Okay? If this is equal to this, we call that 1 radian. Now this is equal to that. Units cancel. So you are dealing with a ratio, is a figure, and therefore this is also a figure. Okay? So if we go back, I conclude what I'm trying to say. Circular motion, in a nutshell, is the motion along a circular path or motion in part of a circle. 2. When a body moves along the circumference, at different points, the speed is the same, but the direction is different, and therefore there is change in velocity. Change in velocity comes from the fact that the movement prescribed there covers some distance in equal time interval. So, vector quantity is said to change when either size is changing or direction is changing or both. And if velocity is changing, we say acceleration exists. And lastly, we talked about angular displacement. It is the angle theta in radians subtended at the center when a body covers some distance along the circumference. Mathematically, theta radians is equal to S over R. Okay? Angle is in radians, and therefore a radian here is the angle subtended at the center of a circle when S is equal to R. Go through it again, just check everything up to where I described that. When we have this example here, you are done. So we shall continue with our lesson 2. Until then, subscribe so that you get notification of what I'm doing. Bye bye.